Swanson, who is a senior information security analyst at the University of California at Santa Cruz. Also, he likes free and open source software. Just FYI. Welcome.
Hello, I'll try to keep it interesting. Actually, somebody told me I should start out with a joke, so I will. Why do bagpipers walk while they play? And you mean, oh, thank you. Well, the answer is to get away from the noise. I'm going to talk about a technique that we implemented at the University of California, Santa Cruz. As John said, my name is Forrest Monson. I'm a senior information security analyst there for a few years now. And almost all of these tools are freely available and can be implemented with resources to which you already have access, likely, and staff. There's some caveats there because, as you know, open source requires money and time that may not be represented. So RTBH. What does RTBH stand for? It's remotely triggered black hole routing. And this is something you should do because I'll give you 3 reasons. First off, you're going to reduce the noise in your environment, and by that I mean the security noise from script kiddies. These are folks who have the ability to download a script and attack you with nothing more than that. Not very much knowledge there. Second, to discourage reconnaissance of your environment, and that's kind of a useful thing if you have things you want to protect, like we do at the university. And third, probably most important, attention is your most precious resource now. And you should spend that, your security team should spend that on attacks that actually matter, not on just the noise. So when we started, before we started this work, one of the problems at UC Santa Cruz is that we mostly had unfettered access from just about anywhere. We had secure enclaves in our environment, but for the most part, folks could look for vulnerabilities at their leisure, which is usually 24/7, and exploit them as they saw fit. And they did, and it was hard to keep up with. It's still hard to keep up with, I'll tell you that. So we were keeping an eye on border traffic already. We were monitoring, but mostly we just watched a lot of these scans, and the brute force attacks kind of slide on by and reacted as we could. So scanning, that's easy to compare to someone going around and trying every single door and window in your neighborhood to see which they can get into. And someone could stop at a scan, of course, but that's when someone's attacking, a scan is almost always one of the very first steps. So we also had lots of brute force attempts. Those online brute force attacks, this is iterating through, as you probably know, usernames and passwords, making many little teeny attempts to get in. And over time they'll get in, unless you have like nose plugs or something. In our case, we needed to hire a bouncer of some kind. So we were letting these folks in, and we didn't want that to occur. So we set this up. To start with, there's open source software at the border. This is Bro IDS that's watching the traffic, and it sounds an alarm when, what in the world? Oh, that's odd. Well, this is a graphic that you can't see, but it shows a monkey screaming at the top of his lungs, and he's sounding an alarm. And this is what Bro does when someone's making brute force attempts or they're rattling windows or doors. This isn't signature-based like Suricata, a tool you probably heard of. It actually looks at traffic transactions instead of just a couple of packets there. So if you make, for you geeks out there, a number of half-open SYN connections to more than 26 hosts within 15 seconds, then we've decided that's not you accessing a website. Why are you looking at 26 different hosts in 15 seconds? You're probably rattling doorknobs and window latches. Or if you try 15 different usernames for Telnet to log in 5 seconds, we've decided that that's our threshold we set, and we said, you're probably not just forgetting your password. You're a very fast brute force attack. So we send these alerts to a queue, and we line up these alerts actually from two different sources now, from our open source software listening at the border, and in addition, a SIM, security incident event management tool that we have. We put these in a queue, which I will go into a little more detail here. The queue holds all these blocking requests that come from the blocking sources, and then a blocking agent can call the queue and ask, do you have any blocks for me to implement? And the queue will say, yes, here they are. It's all speaking through a REST API. This is a flexible architecture. There are multiple sources that can send to the queue, and multiple blocking agents can implement blocks at other locations. The implication of this is you could implement blocks throughout your environment if you wish. We're only doing it at the border at this point. The sources we're using, that is the open source software Bro, as well as our SIM, are blocking for different reasons, because the SIM actually is watching our NetFlow data, and it can react for different reasons than Bro will. We definitely are blocking bad stuff. So here's an IP address that I put into a commercially available threat intelligence tool, they call it. I grabbed it arbitrarily from a list of recent blocks. And this shows, you'll see that it ages over time. So if they haven't taken a known malicious action in recent days, you'll see that over time its score for that particular action is decreased. So this particular IP address was very high, scored very high as an exe source, that's a malicious exe file download, as well as spyware command and control, and regular command and control for malware. And this is actually called emerging threats, is the publicly available source. It's commercially available, excuse me. So when we implemented this, for the first 3 months, we did, there was a rush to get in, as if folks, I guess the tools they were using tried harder. So we had about 26,000 blocks a day at that point, and that's leveled off. And now for the second 3 months, we launched on September 15th. For these second 3 months, we're averaging about 14,000 blocks a day. And at any one time, it's roughly 6,200 blocked IP addresses. So we took that and we correlated these with a publicly available list, that's the emerging threats list, as well as another list called DShield, published by SANS. And what we saw was a dramatic reduction in traffic to known bad IP addresses. This is good news, and it was important to us because we didn't want our hosts talking to, quote, known bad, end quote, hosts on the public internet, because we knew that almost assuredly bad things were happening whenever they would do that. So what we saw is a 94% reduction in alerts for traffic with known bad IP addresses. So we were definitely happy about that. We did get the bouncer in place, and the bouncer is working 24/7, and we consider that to be very effective because it is accomplishing the goals that I discussed earlier. So this is almost all open source. Some of the names here, Bro, Django, Justin Azoff, Postgres, Quagga, and Python will be familiar to technical staff, but there is the need for a border router, and in our case that's Cisco, but whatever you have, as long as it speaks BGP, can do that. So just a little more detail. Here are the pieces you'll need if you're going to build your own and hand it off, if you're going to hand it off to someone, say, please build this for us. First off, you're going to need someone who understands BGP. The headband is optional unless your expert has long hair, in which case it's not optional. BGP is the Border Gateway Protocol, what your router will speak. So this person will need to implement a policy, and peering, of course, you're all familiar with that. The Cisco white paper on RTBH, on black hole routing or filtering, will be important if you're going to implement it the same way we do. And of course, your border router. In my presentation, the Bro Network Security Monitor is the key piece, the sensor that you'll be using. And finally, the physical or virtual machine running the Quagga routing suite, and that's going to be speaking BGP to your border router. And so the last piece is someone who understands Python likely and can set up Django for you. So you can hear there's a need for maybe 1 or 2 staff in there. So when you put this in place, what can you look forward to? How might things change in the future? Well, for us, what we've seen is that the attackers have changed their tactics. We were blocking for very specific attacks and reconnaissance actions, which included the address and port scans, FTP and SSH brute forcing. And the main goal was to decrease noise, so we wouldn't spend so much time chasing down amateur attackers. We wanted to be facing much more skilled attackers. We're not quite there yet, but we have cut out a great portion of the noise, as you saw earlier. So we are seeing folks change tactics now. We are seeing what we call low and slow scans. That is, because I'm using an open source tool, and this is an issue with that, the thresholds that are published are publicly available. So if someone else is smart and they go download the Bro software, they will know that by default, I was looking for 27 different hosts hit within 13 seconds or 15 seconds. And so you'll see folks they'll continue probing, is probably what you'll see. We also see folks moved to other protocols and ports. They moved to remote desktop protocol. We had a lot of folks listening there. And so we are moving people away from RDPing directly into campus, and instead they use campus VPN. So this has pushed other changes. Once we saw that, once that came up to the surface, then we knew we could start, we could have a case to help people change their behavior there and increase our security. And they're also looking at SIP, like our phones, the Session Initiation Protocol for VoIP phones. And so what you'll see is that the types of attacks your staff will see will definitely change, and that they may decrease over time, but they definitely will not stop, for sure. You might additionally want to get visibility inside, because right now we don't have that kind of ability to react. Let's say a student takes a laptop home over the summer and they download some malware and they get infected. Their laptop might attack an on-campus server. If it's not in the data center, of course, we're not going to be able to see that. And we're also not going to block it in any case because it's not transiting our border. So that's something that you need to be aware of. This is only source-based inbound blocking. So again, these are just some things I want to leave you with. It's the stuff here is just about all publicly available. You're going to need maybe 1 or 2 Smarties, but it can be very effective to reduce the noise and the reconnaissance, and we think wasted time spent on folks who are doing nothing more than downloading a script and acting on it. That's really all I have. I want to be sure to thank the folks who made this go on my team, the Network Operations Center, including Mark Paludian, Data Center Operations, and the Infrastructure Security team. So it was a certain amount of work to get that started, but now that we have it in place, it's great. And I'm willing to answer any questions about it, but we'll have to wait for the microphone to, oh, great.
So you mentioned that you're doing 14,000 blocks per day with about 62 active at a time. How long are the blocks in place for?
The default blocking period is no more than 1 hour. We do have an auto scale in place where if someone hits us again as soon as the hour expires, then we just double that each time. And we find actually there are some attackers who never ever stop. They go up to the auto scaling we have in place, doubles to, in some IPs we see for a couple weeks at a time. Thanks. Very good. Oh, yeah.
Did you research any other solutions outside of just open, or what did you say again? Open firmware or whatever?
Yes, we did, and they were prohibitively expensive, and we were relatively young, the team that I'm on now, and thought that we would be, while we could make a case for that, we wanted to do a lot of other things. And actually, that's something I could add. What did we do with all the money that we saved? But, so I don't know how much that was.
Is there, I mean, would there be benefit, though? If they can read the open source, then that's
Yeah.
the only thing I wonder. Would you save more time, or is it not worth the
Oh yeah.
payout?
No, I don't think it would matter. I think that the benefit from sharing that information and the huge swath of attackers who never even bother to do that, but simply turn on a bunch of virtual machines or cloud hosts and attack us. By just cutting those out, that's great. So we're happy with that, even though the thresholds are publicly visible, and you can always change those, like we have. That was just something we noticed early on. Thanks.
Have you shared any of this information with maybe any of the public schools? Because I hear a lot of public schools that have that issue and don't really have the ability to black hole.
Yeah, that is a challenge unless they have one of the firewalls that does that kind of interesting stuff. No, we haven't. We've just started talking about this out in the public, so it's great. And I guess it's an opportunity for us to think about.
That would be a
Like
good
coming to Cenic. That's one thing we've done just now. Anything else? Okay, great.
I just had a quick question. Since you're using open source, do you guys scour the source code? Because how do you not know if there's malware being introduced into the open source code as you implement it?
Yeah, that's a good question. So in the open source community, there's a saying that many eyes make all bugs shallow. And what you're expecting, in our case, we have taken the time to get to know the developers of the tools that we use, except for Quagga, but Mark might know them. So we participate in those communities wherever we can, and that helps us to understand their development process. We don't have the expertise or time to go through to understand all the code, even though it's way more than we would get with a proprietary solution. We rely on the expertise of the developers and the community. Since anybody can go get the source, anybody can examine it. And the theory is that someone would say, hey, what's this doing in there? In a way that they could never do with a proprietary backdoor that you might find that we'd see more often in proprietary appliances. Does that answer? Thanks.
Hi, I was wondering, I came in a little late, so you might have covered this in the presentation
problem.
already, but did you have a lot of problems with false positives, or is your scanning just so specific to certain things, because like Snort or any of the other open source, it will just like blaze you with a bunch of false positives if you turn everything on?
Oh yeah, no, I actually really appreciate that question. Thanks. This was an important issue for us because we didn't want to upset too many people. And as it turns out, with nothing more than the defaults, we found those to be extremely sensible and sane. In fact, in 6 months of blocking at these, thousands of blocks a day, we have received 3 complaints. And one was when I got a little aggressive with a particular policy I had downloaded, and it worked on a development environment that I had quite well, but it turns out that it blocked someone who was using their an older Mac laptop to look for printers. As soon as they fired it up at home, it went to our network and started looking for printers. It's not impossible, but it was something that we handled with our help desk in advance and gave them some tools to deal with these, and that seems to have really helped. There's another question over here. I'll repeat it if you can. Yeah.
I was just going to follow up on what the lady said about the public schools. So do you have any plans to package that, what you got, and make it available to the public schools? Because the K through 12 environment is extremely uninformed, and their networks are wide open for potential bots to launch DDoS against the higher ed.
Yeah. Wow, that's a great question. I appreciate it too, because there is a great need there, isn't there? We haven't yet. We haven't thought about how to package it up. Even though the pieces are out there, it'd be interesting if there's a single. Oh, you know what? There are some packages that are available that would help someone get maybe 75 to 80% of the pieces in place, including the security onion distribution, which is a downloadable virtual machine that would allow you to have blocking and traffic analysis at your border in any case. And then you'd need someone who could implement the blocking. I'll ask you a question after I get down from the podium, and you can tell me what we would do if we were gonna give it to public schools. Thanks. Anything else? Okay. Thank you all, and happy blocking.